Hi guys, I'm back. I've changed my location. I decided not to take over my daughter's room anymore, so I've moved out to my little cabin in my backyard. So we will do the rest of the lessons from here, I think, as long as it works well. I'm hoping not to have too much glare. I've kind of blocked off the windows to try the best I can to see what's happening. Okay, today we're going to do factoring a difference and a sum of cubes. So you've seen this idea before with difference of squares, and to sort of remind you what that was all about, when we did a difference of squares, the idea was that it was a binomial. So you had in the note, you'll see there's an example, x squared minus 25, and the second example is x to the 4 minus 81, y to the 4. Can you come say hi? Sure, come on over. Oh, Morgan. Say hi.
Hi.
All right, you can go back to your stickers. Morgan's working on a sticker thing.
Bunny.
A bunny sticker. She'll show us at the end. Okay, go over. Okay, so when you look at the difference of squares, the idea was that you have these two binomials. Different than the trinomials we've been factoring. And what you need to remember about the binomials is that both of them are what we call perfect squares. They're perfectly square rootable. So you might remember when we factor them, and in both cases, they both get put into a set of brackets. And really the trick that we used was that we took the square root of the first term. So in the case, the square root of x squared is just x, and you put that in the beginning of each set of brackets. And then you take the square root of the second term. In this case, 25, the square root is 5, and 1 gets a positive, and 1 gets a negative. Okay, remember what you're really doing is this was the same thing as saying x squared plus 0x minus 25. And the idea is if you did simple trinomial factoring, you would be finding two numbers that multiply to negative 25 and add to 0. So you'd say, oh, positive 5 and negative 5 multiply to negative 25, but they add to 0. Okay, so that's the idea with the difference of squares. Up here, neither of these are squared. They're to the power of 4, but the same thing applies. When you take the square root of something to the power of 4, you get something squared. So you get 2x squared at the beginning, and then when you take the square root of 81y to the 4, you get 9y squared. 1 gets a positive, 1 gets a negative. And that was how we factored a difference of squares. Now, when we apply this sort of idea to a difference of cubes, the thing that's going to be similar is it also has a trick in it, in the way that there's actually sort of a short-formed formula instead of having to go through all the synthetic division, instead of having to do it like that. So what we're going to learn is the short form for how to do a difference of cubes, as well as a sum of cubes. So with difference of squares, it was always a subtraction sign, hence the word difference, and we didn't do a sum of squares. There was no trick for us to do that. Okay, so if I erase this for a second. Ben, you want to come say hi? Or no?
I said hi, Ben.
Both my kids have come out, so. Okay, so if we try to do a difference of cubes, so I want to make sure I use these ones again. We have x cubed minus 8 as one of them. And then we have x cubed minus 27. And what we want to look at here is the idea that if we were to factor these the way we factored in the last lesson, and we wanted to look for something, remember we kind of make this p of x is x cubed minus 8. You're looking for a value of x which gives this an answer of 0, the whole idea that you have a remainder of 0. So you know when you sub, guys, get out of the way. When you sub a 2 in for x, p of 2, you get 2 cubed minus 8. 2 cubed is 8. 8 minus 8 is 0. This makes us happy. That means we know that x minus 2 is a factor. Okay, that's what we learned from that part. If you then set up the synthetic division, you put a 2 here, because we know that's the factor, and then you list the coefficients here. Remember, the coefficient on x cubed is a 1. There is no x squared, you'd have to put a 0. There is no x term, you'd have to put a 0. However, there is a negative 8 as your constant at the end. Now remember with this one, synthetic division you should be really good at by this point. You bring the 1 down. 1 times 2 is 2. Remember, you add the columns, 2. 2 times 2 is 4. Add the column. 2 times 4 is 8. Add the column. You get a remainder of 0, exactly what you wanted. So we now know that these are factors. X minus 2 is the first one. And then what does this correspond to? Remember, this first term is a constant. The second term has an x value, and the third term is of degree 2. So we have x squared plus 2x plus 4. Okay, and that is going to equal x cubed minus 8. Now, if this was the way that we did it in the last lesson, we would have just said, okay, now factor this trinomial. Okay, now factor this trinomial if you can. However, this one is not factorable. There's no two numbers that multiply to 4 and add to 2. So that's as far as we can go right now without having to use the quadratic formula. Okay? So, there's choices. Do you want to do it this way every single time? This takes a little bit of time. Or you start to look for what is the pattern. Okay? So if you take a look here, there's a bunch of numbers. You're trying to factor x cubed minus 8. Okay? We found out that 2 is a factor. Does it surprise you? When you plugged a 2 in here, 2 cubed minus 8 became 0. So that one's pretty easy to identify. Okay? Now, when you look at the number 8, how is the number 8 related to 4 and 2?
Oh, I know.
How?
Because they're all even.
Okay, they are all even.
Yeah.
But also 2 times 4 is 8. So that's sort of how that is going to be related. Now there is a general formula that I'm going to write on the bottom that will tell you exactly what this is. So when you're doing a difference of cubes, so we have a cubed minus b cubed, it is going to equal, Morgan, stop, a minus b, and then on the other side, a squared plus ab plus b squared. Okay, that's going to be the general formula. So let's make sure this works for this one. To get here, we had to cube root the a cubed to get a. So a cubed root of x cubed is just x. The cubed root of 8 is 2. That's where that came in. Now the next one's going to be your a value squared. Our a value is an x. So we get x squared. The middle term is going to be a times b. Our a is x, our b is 2, so we get a 2x. And our last term is going to be b squared. Our b value was 2. 2 squared is 4. So let's try it on this one.
Wait, where's the C?
There's no c for this. So the idea here is, in this situation here, our a value is going to be the cubed root of x cubed, so just an x. Our b value will be the cubed root of 27. What is the cubed root of 27? 3. To factor this, we simply set it up in this way. When you factor that, you get a minus b, follow the general term, a squared plus ab plus b squared. And simply plug in your values. Our a is an x, our b is a 3. Substitute that in. And then we have a squared, x squared, plus a times b, 3x, plus b squared. 3 squared is 9. And that's it. So what would you rather? Go through this whole process of finding p of x, substituting in the proper term, using synthetic division, or just using the quick method? I think for the most part, everyone would choose the quick method no matter what.
I would.
Right? You would choose the quick method?
I don't even know what that is, but okay.
Okay. So that is a difference of cubes. Now, a sum of cubes is going to be similar in that it has a short form. So let's take a look at that one.
3D shape.
Okay, there is a PowerPoint for this note, so you should be able to look at the PowerPoint. Most of it's filled in. I'm picking and choosing, Ben, watch it. I'm picking and choosing examples that I think are fairly similar to the ones that are in the note or are the same, and then doing them. Just get out of the way, please.
Why?
Okay, so a sum of cubes, they give the exact same examples. X cubed plus 8 this time. So we're using the same values, but we're going to add instead of subtract.
I don't know.
And x cubed plus 27. Those are the first two ones that we investigate. Now, in a similar way, you're going to set up a way that makes life a little bit easier. So when you are factoring a cubed plus b cubed, you're going to get, as you guess, instead of a minus b, like in the difference of cubes, you get a plus b in the sum of cubes. And then on the other side, you're going to get a squared again. It's going to end with b squared. But what do you think is going to happen in the middle? Before we had plus 2ab or plus ab, and now we have minus ab. Okay? That is the general term for a sum of cubes. And in order for you to solve, all you have to do is identify what is your a, what is your b. Okay, so in this sort of idea here, I would say, okay, I have an a value of x. I have a b value of 2. Because remember, you are taking the cubed root of each of those. When I substitute it into this, I get a plus b, x plus 2. And on this side, I get x squared, a squared, minus 2x plus 4. Okay, similar yet different. The differences are this sign and this sign. Otherwise, they're the exact same general formula. Okay, so just be a little bit careful when you're doing it. When you do this side, again, identify what your a is by taking the cubed root. And then it's just a matter of substituting in, right? X plus 3 this time, x squared minus 3x plus 9. Okay? That should be fairly straightforward on how you do it. Remember, in some situations, and when you look at what's going on in the bottom part of this note, there's a couple other examples which you may have to factor first. So a lot of times you have to common factor first in order to get the total idea of what's happening. So if I do the last couple examples with you. Okay, the first one is saying 8x cubed plus 125. Okay, this one there's no factoring that you have to do. You just have to be aware. I don't need to solve it all. I'm trusting you can plug it into the equation yourself, but I'll help you identify what is your a value, what is your b value. So again, you're taking the cubed root. The cubed root of 8 is 2. The cubed root of x cubed is just x. So the cubed root of 8x cubed is 2x. The cubed root of 125, remember there's a button on your calculator. It'll be like n root x, maybe y root x, where you can take cubed roots. And the cubed root of 125 is 5. It's saying what number multiplied by itself 3 times gives you 125. 5 times 5 is 25. Times 5 again is 125. Once you know those, you can substitute them into the equation. So I just want to start these for you. Okay, just a second, Morgan. Just a second. So the next one, that was A. B said 7x to the 4 minus 448x. Okay, you'll notice on this one, a couple things look very funny right from the beginning. 7 is not a perfect cube. 448 is not a perfect cube. X to the 4 is not a perfect cube. Neither is x. This does not look like a difference of cubes at all. If, however, you common factor the 7x out, you'll be left with x cubed here. And how many times does 7 go into 448? 64. Now, you can leave this 7x out front. This is a difference of cubes. You can set it up in the way that, in this case here, your a is x and your b is 4. And then you can set it up. X minus 4 here, x squared plus 4x plus 16. Okay, So just be very careful that in certain situations you will have to common factor first, or maybe do something a little bit ahead of time. Okay, Morgan. Okay, Morgan wants to show you what she completed while she was half distracting us. Oh, a sticker page of a bunny. So this is how this works. This is a good activity. These all have a number with a code. See those? And she's got to match the sticker number to the sticker on a page and then post it to make a picture. Great?
Yes.
Okay.
And I made a bunny with a heart.
Yes. Okay, say see you next week.
See you next week.
Why are you talking like that? So talk normal.
See you next week.
Okay, can you press this end button?
And what?
The red button.
The red button.